All right. I even did these this morning, so I should have some answers. This one is super important, and it's super important for like FRQ purposes, because very often one of the early questions is some sort of problem in context. They'll ask you questions about the derivative. They'll ask you questions where you need to integrate, and it's all mixed up together. So we talked a lot about differentiation in context. We know how to put we should know. We might have to remember, but we know how to put our sentences together to describe what a derivative means. Today we're going to figure out what an integral means, and we're going to do most of it calculator active. So that makes life better. So example number one, there's a couple little important details in this. Although before I even get to that, I'm going to say this. I know I have this sentences written similar to this in a couple other spots, but it's worth saying over and over again. When we integrate, we are integrating a rate of change. Right? The thing that we're integrating is the derivative of something else. It's a rate that we're integrating because we're working our way back up the ladder, right? I always refer to taking the derivative as going down the ladder. We're integrating, we're going back up the ladder. So we are integrating some rate to see how much the quantity that rate is about has changed, right? That's what integrating tells us. So hopefully, in more clear-cut words, we'll have this in example one. It says a storm has washed away sand from a beach, causing the edge of the water to get closer to a nearby road. The rate at which the distance between the road and the edge of the water was decreasing during the storm is modeled by this function, which is measured in feet per hour, and t is how many hours it's been since the storm began. The edge of the water was 200 feet from the road when the storm began. If the storm lasted 4 hours, how far is the water from the road after the storm? Okay. So the idea is when we integrate that rate, so if I integrate r of t dt, and we're going to do it from 0 to 4, right? So I'm going to put those limits in from the beginning of the storm till 4 hours into the storm. This will tell how much the distance between the edge of the road and the water has decreased. A small detail about signs, and this is important. I think it's pretty consistent from the way I've read through problems. The distance is going to decrease between the road and the water, right? That does not mean that this integral is going to be negative. Think about how you would write this problem if rather than giving you a function, I was actually giving you a measurement, right? If I said the distance between the edge of the water and the road has decreased by this many feet per hour, would I be giving you a negative number there? Would I say it decreased by negative 3 feet per hour? No. So very often these functions, even if they represent something decreasing, the function is telling you the size of that decrease, so that function ends up being positive. So that's really important to know about these functions. As a matter of fact, since we're integrating e to something, which is finding the area under the curve, this function is exclusively above the x-axis, so we would absolutely have to get a positive value from this one. So just be really careful with that. And I mean, if you're in your head about it, at the worst case scenario, just look at the sign of what you get when you integrate and make sure it's the right one. You know what I mean? Do I need to subtract this, or is the subtraction already built in? The answer is no. I'm going to have to subtract this because the subtraction is not built into it. Okay, so How are we going to figure out then how far away it is? If this tells us how much the distance has decreased, I'm just going to take that 200 and subtract, because I know it's going to, because of the word decrease, that's where the subtraction comes in, 0 to 4 of r of t dt. So this is where you can take out your calculators. We actually could not integrate this. I don't know if there is a way to integrate this, because e to the negative sine t, the only way we know how to do it would be u substitution. And if I said that u was sine t, there's no cosine anywhere. So u substitution would not work with this, but this isn't designed for u substitution. This is designed for you to put in your calculator and see what you get. And like I said before, if you're really not sure about the signs, I might just do it in 2 steps. I might do the integral first to verify whether you're getting a positive or negative result. We got e to the negative sine t. You know, if that gave you a negative, you would know to add it, just to make sense in the problem. And if it gave you a positive, then you know you need to subtract it, and then you can show your work based on what that's going to be. And it ends up being 200 minus the answer. In my case, the answer, which is going to give me 196.937. Okay. Questions on that one? So taking those problems a step further, this is a really common type of setup that they'll give us on an FRQ. We call this a rate in and rate out problem because we have a situation where there's something to cause your quantity to increase, and there's also something to cause your quantity to decrease. And you know, you've got to incorporate both of those, which sort of ends up meaning two separate integrals. So let's take a look at how it's working out in this one. Here, the thing that's increasing and decreasing is the number of employees inside of a large office building. So this is what a calculator active FRQ looks like if you're taking an integral. We're not doing anything about this by hand. At 7 a.m., there are 43 employees in a large office building. Employees enter the building at a rate modeled by this rate right here. T is how many hours it's been since 7 a.m. Due to a company policy, from 7 a.m. to 9 a.m., nobody leaves the building. But starting at 9 a.m., employees leave the building at a rate modeled by this function, which again, totally something for a calculator active question. So you've got to read the questions carefully to see what you have to put into each problem. Letter A says, how many employees are there in the building at 9 a.m.? Okay, so we want to know the total number of people in the building at 9 a.m. So what we have to do in a problem like that is we've got to take the 43 that were already there and add however many enter the building between 7 a.m. and 9 a.m., which conveniently nobody leaves the building. No fire drills between 7 and 9 a.m. in this building. Big, tough guys not letting you out. So how do I figure out how many employees entered the building between 7 a.m. and 9 a.m.? It would be from 0 to 2 because 7 a.m. is your starting time. Yep, T is the number of hours since 7 a.m. So yeah, so we'll integrate from 0 to 2. We're going to integrate G of T because that's how many entered. This sort of question, and this is just a good general overall strategy, I may have to use these equations multiple times. They're bare to type in, so these are the ones I'm going to put them in for y1 and y2 before I do anything else. So I'm going to take 25 math abs quantity 10 minus t, or 10 minus x, sine of pi t over 5. X over 5. The more I've been looking at problems, the more that I've noticed that AP does do a good job of putting parentheses around there. Like I was talking about with the pi over 6t the other day, like they do a good job of that. So I still think what I said was valid, but luckily it won't be an issue for us. Got that good? Yeah. 97 minus 181 cosine second pi t minus 2t double parenthesis there. All right, let's see how many people get matching answers and how many people don't. I'd say be careful with this pi t minus 2t over 2.9 business. You got to make sure you put your pi x minus 2x in parentheses, or use alpha y equals for the fraction. But both work. So hopefully I have them in right. We'll see if they match the answers I got earlier. So my g is my y1, obviously, and my f is my y2. So I'm going to do 43 plus the integral. Where's that at? Alpha f2. No, that's f of t. Right? I mean, they're labeled up here. You're good. Yeah. Alpha f4. So I'm going to go 0 to 2. I'm going to put alpha y1 and dx. Oh, vars works too. Yep. Vars does the same thing. Yeah. Yep. It's just a couple more presses, I think. That's what I used to use, and then I got myself in the habit of. Yep. No, I lie because I don't have any answer here. So who knows? I just wrote down the math, but never actually did it this morning. Do we get the same answer? Cool. Okay, so AP, what I'm going to do is I'm going to write, because this is an expression, and this plus this equals this. And if I really feel weird about the fact that you can't have 0.297 employees, I'll say a separate sentence about 282 employees. So 282.297, and say about 282 employees.
Would you get docked points if you were to not write the about 280?
I don't think so, no. That's why I prefaced it with, like, if you feel weird. We'll definitely look when we get, when we start doing our prep, we'll look at their scoring guidelines and really nail stuff like that in and hopefully find some examples. But yeah, I know the question that this is modeled off of was talking about pounds of things. So with that one, you could have 0.297 pounds, but this one is strictly people. No, I think you're good. I think you've covered all your bases, and I don't, unless it says specifically something in there like that, I think you're relatively good.
Are you usually good to do like a roughly equals to sign instead of?
That's a good question. I don't know that off the top of my head, but I think what you're saying though, when you think about it, is if you put roughly 282, you're saying the exact same thing as I'm saying by writing it. So I think that's generally how they figure those things out. Like what would be the difference between one person putting roughly 282 and somebody else writing a separate sentence? I think we're good. Yeah. That usually is the best way to sort of figure out like what they're going to actually do is that way. But yeah, I mean, they can't take off for correctly equal expressions that are the right thing to do. So I like having that there. That is the answer to the integral, and then that answers their question. How many employees have left the building by 3 p.m.? Look at questions A and B, and this kind of goes right to the two cards that I gave you at the beginning of class. So like this one, we want to know what the total is in the building. Are we asking for the total here, or are we just asking for the change? Just the change. So all we need here is the integral, right? So careful on this one though, because, and like I said, I know this is exactly something that happens in a different problem that was given on the AP test. What t value is 3 p.m.? Yeah. All right. So we are going to integrate from what to 8? 2 to 8, because nobody has left the building. If you integrated from 0 to 8, you'd have people following this function leaving the building for those first 2 hours, and you would get probably too big of a number. So 2 to 8 of y2, if that's how you did it. Because we're only looking for the change, we only need the integral. Yep. Good call. Yeah, it's never a time when you're allowed to not have that at the end of the integral. 2 to 8 of alpha y2 this time, and dx. Wow, that's a lot. I mean, I guess this was a lot more time, right? Is that what you guys got?
I got exactly.
I got 729.
I got 729.
That's well. What did I see? 97. Oh, that's funny. Just a wrong number. Straight up, there's a bad wrong number in there. Okay. It's a large building. Yeah. Yeah. Yep. It's a big skyscraper with different businesses. 729 point. I mean, there's almost two. I mean, there's almost 150. There's less than 150 teachers in the building, but you know, custodians, things like that. I mean, this isn't I picture a large building. I picture a big complex. Anyway, so we got 729.345. Thank you. And save thing.
So why those plugs in the cards?
So I'm saying that these are a rate. So I needed on the cards, I needed to have this function named, and right now we don't have a function named for how many people there are in the building, right? So if I said that if I had said that g of t is the number of people different problem, g of t is the number of people that entered the building, then I'd be doing the integral of g prime of t. It's actually just different notations based on the situations, scenario, etc. Yep. No, it is. That part does get a little bit tricky when you think about it. What it comes down to is just what the original information was given to you. These functions are rates, but we're not calling them derivatives of another function. That's really the main difference. You've always got to integrate a rate, whether it's just a named function or a named function's derivative. I guess that's the question. What's the named function? Are we naming the rate or are we naming the total? And in this case, they named the rates, and we just don't have a name for the total. We could use like a capital G or capital F in those situations. How many employees are in the building at 5 p.m.? So now we've got to bring people in and take people out. Do we want to change or a total? Total. So we've got to start out with our 43 plus. And then we'll just do plus the integral for g of t and minus the integral for f of t. If 3 was 8, then 5 must be 10. So we'll go from 0 to 10 on f of t, on g of t. I don't know why they wrote them backwards. G before f. And then we'll subtract 2 to 10 of f of t dt. This is not an AP problem, but this is one that somebody wrote based on an AP problem. Do we get a weird answer?
We get a negative 200 to 200.
Ah, all right, nice. Yeah.
So here's the question: is the answer 0?
That's a good question. Right. Yeah. That's weird. I'll have to go back and look at his notes. I believe that an AP question would be screened better than this. Although I did trust this is. I'm pretty sure this is Passwater, and his stuff's usually pretty good. The integral from Right, because this was positive. Yeah. Yeah, I guess that makes sense. Okay. What did you guys end up getting? So I don't have to type it in. Negative 229. 879. Cool. Roughly zero. Yeah. Bad question. I'm not gonna write. Yeah. That's odd. Yeah. Yeah. F of t. I don't know why he did that too with the G first and the F second. It's kind of annoying. Yeah, I would have, because I almost made that mistake earlier. Yeah, you would think he would have spot checked this question a little bit better. I don't know. It's also possible that I may have changed the question and added 5 p.m. there, and his original question didn't go that deep. But anyway, last but not least, and this is kind of a takeoff of what we did in letter C. So you wouldn't probably see both of these in the same question, but it says to write an integral equation for P of t. So now they are naming a function where P of t gives the number of employees in the building at any time for 2 to t to 10. Really, it's just taking the same question we answered above with letter C, but now our t is just a variable. So we're literally going to rewrite the same expression, but we are going to put t's here. We also need to be careful because if we put t's here, we've got to change our variables down here. Not that I feel like they would have maybe done a better job of. They were nice, and because we're completely restricted from 2 to 10, we're not allowed to put anything bigger or anything smaller than 2 in, so we're never going to have an issue with t not being in the domain. That's a good question, but no, they specifically, you would have an issue because you'd have to do something different if this was from 0 to 10, because you would have to eliminate the f of t between 0 and 2 because nobody's leaving the building. So the correct answer for this would be just replacing those 10s with t's. We do need to use a different variable here. So I'm going to do g of x dx, and then minus 2 to t g of f of x dx. T is between 2 and 10, so you're always going to be good because you'll always be integrating g from 0 to whatever your t value is, and you'll always be integrating f from 2 to whatever your t value is. And you can't put anything less than 2 in, so this isn't going to give you something that wouldn't be legitimate. All right, 2 more examples that kind of bring some tables into the mix, and that notation thing is going to come up again with the prime and the not prime, because I believe both of these examples come off the same starting value. So this is a really good one to really get the difference between how they label things and what they're saying in the problems. So in example 3, water is pumped into a tank at a rate modeled by R of t. So we're naming the rate in this one, where R is differentiable and decreasing on the interval of t between 0 and 8. Selected values are given below. At time t equals 0, there are 5,000 liters of water in the tank. So R is our rate, and this 5,000 is our quantity that the rate is changing. So we don't have that named in this one. We don't, have the antiderivative of R labeled. So if I integrate 0 to 8 of this rate, R of t, what does that represent? No. In 8 hours. An integral by itself is just the change. The only way that this would represent how much water was in the tank would be if the starting value was 0. An empty tank would have this much water in it after 8 hours. But this is how much water was added to the tank. How many liters were added to the tank? I'll even use the label. And try to avoid saying things like in 8 hours. Say from t equals 0 to t equals 8. Just because it can be ambiguous in some situations. We did that with derivatives too. When we were evaluating a derivative at a time, we were saying at t equals. Well, an integral stretches over an interval. Say that 10 times fast. I couldn't do it once. Okay. Estimate that integral using a left Riemann sum. So this can happen where the intervals aren't even, and that's fine. Sometimes they might give a little bit more in the explanation, but whether they give a little bit more or not, they want you to use the intervals shown here. The first interval has a width of 1, the next interval has a width of 2, the next interval has a width of 3, and the next interval has a width of 2. So we'll be multiplying by each of those, and the left Riemann says that, when I'm looking at this interval, I'm picking the number on the left. For a right Riemann, with this interval, I'd pick the number on the right. So it's going to be from 0 to 1, it's going to be 3,000 times that interval length, which is 1. The next interval is from 1 to 3, so it'll be 2,500, the left, times 2. Then we'll do 2,100 times 3. And then finally 1,500 times 2. Oh, look at I did this one in my head. 3,000, 6,000, 8,500. No, 3,000, 6,000, 11,000 plus 6,100, 17,300, right? Yeah. Cool. It does not say to use, it doesn't say to label it, but what would the label on that be? Just liters, yep. Yeah. Which I guess maybe it didn't say that because we answered it up here. That number is how many liters were added to the tank from t equals 0 to t equals 8. So again, now the separate question, based on that estimate, how many liters of water are in the tank after 8 hours? Yeah, 5,000. We're going to just add those up. The initial starting amount plus the change. Boom. Perfect. And that's going to be 22,300. Yes. Yep. Yeah, if we weren't, we would have no way to answer that. Yep. And now, nicely, that initial amount was t equals 0, which was the start of our integral. Alrighty. All right. Same scenario as example 3, but this time we're naming the function which is how much water is in the tank. So now the values in our table are how much water is in our tank. What does the integral from 0 to 8 of w prime represent? Not that we have w prime, but what is it? Right. It actually represents the exact same thing our integral from above represented. Right? So this is, because this is the rate at which the liters are entering the tank. So when you integrate, just like before, when you integrate the rate that the liters are entering the tank, it's actually the same thing. So it is literally the same words from above. How many liters of water are pumped into the tank between t equals 0 and t equals 8? So again, you can start to see, between Aiden's question and just these two very parallel but very different examples, it's all about what they decide to name. Do they name the total? Do they name the rate? If they name the rate, then that's what you're going to see in the integral. If they name the total, then you're going to see that total's derivative in the integral. how the heck are we going to find the integral from 0 to 8 of w prime if we don't have w prime? So easy.
How we estimate the rate of
Nope.
change, though.
It's just W of T over that.
Right. So say what you mean a little better.
Then,
It's just 100,000.
No, it's not 22,000. Nope.
Oh, yeah.
Yes. Yeah, it's 17,000. So actually what this is, guys, what's really going on here, but you're right, like if you know what it means in context, well, how many liters of water were pumped in? We went from 22,000 to 5,000. Or we went other way around, I said it backwards. We went from 5,000 to 22,000, so we have to subtract those out, and that gives us 17,000. But what's really going on here is we just used the fundamental theorem of calculus. Because the fundamental theorem of calculus says that this integral is the antiderivative of w prime, which is w. So evaluated at the higher number minus that same antiderivative, which we just happen to have one, at the lower number, which is, that's what those numbers are. That's what you guys did. That's what you guys did naturally. So you guys just naturally did the fundamental theorem of calculus without doing the fundamental theorem of calculus. Fun stuff. It is something like, yep. All right. There we go. All right, so 20 minutes to zip through that. I'm pretty sure almost everything there is designed to be calculator active. Oh, cool. Yeah, and if you have homework to show me, like I could pretend like I actually do my job. Yeah, go for it. Glad I have that recorded.